So this is going to be a really brief video. I've already kind of showed you how to implement functions in Excel. And so all we're going to do now is kind of introduce you to the function for implementing a tTest statistical test into Excel. And so here what I've got is the horsepower of those car data for manual and automatic transmissions. And you've already generated these summary statistics yourself. And so now we want to know, okay, so our means look a little bit different. But remember what I said early on is that the mean's not really everything. There's a lot of other important factors like the standard deviation around those means. And so even though we see that the means here are different of 160 horsepower versus 126 on average between a manual and automatic transmission, that actually might just be some sampling bias or sampling error. They might not actually come from underlyingly different distributions of horsepower if you were to look at all automatics and all manual transmissions. So how do we statistically test that? Well, you've kind of been introduced to the tTest now, so I'm just going to show you very briefly how to implement it. So we have our columns here of all the horsepower data for manual transmissions and automatic transmissions. And so all we're going to do is just like our summary statistics, functions are going to begin with an equal sign. And here we're going to say t.test. And you can see it's already predicting what I want to type. If we go ahead and click on that function, remember Excel gives you hints on what it wants for each thing. And so it wants an array 1 and array 2. Array, again, is just kind of a fancy word for list. And so it wants the list of one treatment or group, so the manual horsepower. And then array 2 will be the other one that we're comparing it to. So what we're going to do is we're going to click and drag for array 1. And then it wants a comma to move on to array 2. We'll give it a comma, and we'll do array 2. Okay, just like that. Now, this is where it gets a little tricky. Now it's going to ask for something called tails. So we'll type a comma. And what tails have to do with are whether you're trying to predict or trying to infer if there's any difference at all, or if you're more interested in a direction. So again, if we think back to the Khan Academy video on statistical tests, we see that distributions are those kind of normal, kind of hump-shaped distributions, kind of like that, if you look at my cursor. And so a two-tailed t-test is looking for any difference, either smaller or larger, between these. So basically, we're testing whether automatic horsepower is higher or lower than a manual horsepower. A one-tailed t-test has a directionality. You're specifically testing, we hypothesize that automatic horsepower will be greater than manual. And if it turns out to be lower, you're going to fail that t-test. So in most cases, you're probably going to use a two-tailed t-test because many times we're just looking at, hey, is there a difference? Not, is the difference in a specific direction? And so if you want to know more about that, I've attached a link that goes into much more depth into one versus two-tailed t-tests and kind of the implications there. You can click that link in the video if you're interested. But if you just want to kind of get on with doing a two-tailed t-test, all you have to do is hit 2 for the number of tails right here. And then finally, we have to choose the type of t-test. There are 2 primary types of t-test. Again, we're not going to get into the nitty-gritty of these things, but one is a paired t-test, and that would be a 1 here. Paired t-tests are very special situations. That's where the columns actually match. They're a matched pair, a paired t-test, where, let's say this 62 here is related to this 93 in a way that it's not related to this 66. An example would be if you were testing patients before and after some kind of drug dose. You could think about blood pressure in a patient before and after you give them blood pressure medication. There's a connection between these 2 points in these columns. And so you want to retain that information, and a paired t-test does that. An unpaired t-test assumes no relationship between the ordering of either column. We're just looking at a string of manual horsepowers and a string of automatic horsepowers. This top one has nothing more in common with the other top one than it does with the bottom one. And so in most cases, you're going to be using an unpaired t-test, which is also a 2. And so to reiterate, what we did is we did array 1, array 2, a two-tailed t-test, and a 2 for unpaired t-test. And so we're going to go ahead and hit enter now. And this is our p-value. So again, recall the Khan Academy video, what a p-value actually represents. Here it's 0.178 or so, and some change, or depending if you round. And so what this means is that if we reject the null and say that there is a significant difference between horsepower across manual and automatic transmissions, there is roughly an 18% chance that we would be incorrect in doing that based on random sampling of all of the cars. And so that's just too risky for us. In science, we like that to be less than a 5% chance. So we really only tend to, we'll call this the p-value, we really only tend to reject the null hypothesis and accept the alternative that our two columns are different or our two groups are different if our p-value is less than 0.05. So it could be 0.01, 0.01, or 0.049, something below a 5% chance, 1 in 20. And so this is probably a little unsatisfying. We saw a pretty big difference in the mean, but recall the standard deviations here are quite large. And so now on your own, you're going to do the exact same thing, but now you're going to do it with this other data set that I'm going to provide. It's set up exactly the same way as the horsepower data, but now we're going to be looking at miles per gallon in manual versus automatic transmissions. And so you're going to be doing the equals t-test and filling in a two-tailed type 2 or unpaired t-test and interpreting the p-value that you get here, whether you have evidence to reject the null hypothesis of there being no difference between manual and automatic miles per gallon, or reject the null hypothesis and accept the alternative that there is a difference between them.